y. Do you agree with this? Take x and y. This is how it looks like, right? So since y is any point in the domain of f, choose y equal to let's say x star. Let's choose y equal to x star. So what will happen? This will be p star is greater than or equal to f of x minus 1 by 2 lambda norm of f of x, gradient of f of x square, right? So now if I take it to the other side, or by rearranging, what do we have? We have f of x minus p star, this is the gap, right, is less than or equal to, right, 1 by 2 lambda the gradient of f of x square, right? So that means if your gradient is small, the gap is also small. Do you agree? Do you agree? So now all that I can say is if the gradient, right, so f of x whole squared is less than or equal to, I'll make this very small. How small? I'll make it some epsilon, right? So in fact I'll make it 2 lambda epsilon, right, less than or equal to 2 lambda epsilon implies f of x minus p star is less than or equal to epsilon. Do you agree with this? Is the flow clear? So all that I'm saying is a very intuitive statement. That is, if the gradient is small, then the gap is also small, which is very, very intuitive for convex functions, right? Strictly convex functions. So this is an important result. So how do I choose? If the gradient is less than 2 lambda epsilon, where did I get 2 lambda epsilon? Because if I substitute 2 lambda epsilon here, 2 lambda cancels and you get epsilon. So gap is less than or equal to, this is the gap, right? So what is this gap? This is the gap, right? So this is the gap, right? The gap is small provided the gradient is small. Is that fine, everyone? Any questions? Is there any questions? No? Fine? Okay. So I have to fix this now. So how did we, where did we go wrong? Okay. Maybe let's revisit. Let's not do this. Let's keep this as is. Okay. F of xt. So this is greater than or equal to, let me call this whole constant as alpha. Okay, so it's alpha times the gradient squared, right? So let me call this as 1. So this is what we have, right? From 1, we have f of xt plus 1 minus f of xt is what? Is greater than or equal to alpha times the gradient of f of xt whole squared. Okay. If I sum both sides from t overall t from 0 to capital T, what do I get? Okay, so summation t equal to 0 to capital T f of xt plus 1 f of xt is greater than or equal to alpha times t equal to 0 to capital T the gradient of, okay, fine. But this is greater than or equal to alpha times. So if you have, let's say, 3 numbers a plus b plus c, that's always greater than or equal to 3 times the smallest, right? Do you agree? 1 plus 2 plus 3 is always greater than or equal to 3 because 3 times 1 is the least. So I'll do the following. So min over all t gradient of f of xt